Hello everyone. Today let us learn to build an app in Devum, where we will create a pop-up using click event and behaviors. In Devum, creating a pop-up to your app with an on-click event is simple using our what you see is what you get IDE. To make things simple, we will build this app in 4 steps. We will start with building the app page layout design. Then we will learn to bind data source to the app, add on-click event and build the pop-up. And in the end, we will add behavior. For our example, we are building an employee directory where clicking on a specific employee record will open a pop-up displaying other details for that specific employee. We will also learn how the layout and styling of app interface should match with the one you see here now. To begin with building, we sketched schematic diagrams of different app screens to prevent multiple iterations before building in Devum. You can use paper or your favorite diagramming tool for that. We have created schematic diagrams for each screen, one for the main app, one for the employee list, and one for the pop-up. These help understand the Devum elements needed and the sequence to add them. To start building our app, we have already added grid and container components to the canvas. To design the left panel of our app, we will add a label element and a list element inside the existing container component. We will switch to the Outline tab to get a better micro-level control of each element on the canvas. This helps us select the nested label element to change the default text to Personnel Listing from the Data Binding option. We will look deeper into data binding in the next episode. To style a label component, we will move to the Properties panel. For a label, we will be focusing on updating its typography in terms of selecting a desired font and its size, adding font colors or background colors, desired text alignment, and much more text formatting options. For our app, we are selecting center justification and adding a border, which can be styled further in terms of its width, color, etc. Proceeding with the design, we will introduce new child components within the existing container component. We will be adding an image element and another container element as the child components. For the image component from the Properties panel, we will set the component's dimensions, that is height and width to 50 pixels by 50 pixels. To ensure proper spacing and alignment within the parent container, we will apply display layout as flex to the container and fine-tune its properties, including direction, wrap, align items, and justify content. To further structure the content, we will incorporate 3 label components as additional child elements within the second container beside image component. Therefore, we are adding 3 label components one after the other. To enhance the layout aesthetics, we'll again apply display layout as flex to its parent container and add 20 pixels of padding for better spacing. This hierarchical arrangement will provide a clear and organized foundation for the subsequent design steps. To modify the visual arrangement of the child component, we will access the Properties panel from the overarching master component. This centralized control hub allows us to make precise adjustments to the child component's layout within its designated container, ensuring a cohesive and visually appealing design. The moment we change the layout of that container, we see how the orientation of the component is going to change. To enhance the visual appeal and spacing of our component, we will adjust the padding. By doing so, we can prevent the component from appearing overly close to the left edge of the app interface. Additionally, introducing padding will create a visually pleasing separation between the component and the interface border. To achieve the desired look and fit, we will also fine-tune the component's height and width, as shown in the video. We will apply Flex Model to the container by setting Display as Flex and adjusting flex properties like Direction, Wrap, Align, Distribute to control child elements' placement within container. The applied padding has significantly improved the component's visual clarity. The spacing between the component and the interface now appears balanced and aesthetically pleasing. And there you have it. We've successfully achieved our desired app interface layout. Please ensure that all your workings are published. Join us for our next episode to explore more on data binding. Thank you for watching. Welcome to episode 2 of our use case scenario. In our previous episode, we have seen how to build app interface layout. In this episode, we will delve into data source binding. Data binding in a low-code platform provides user with the capability to establish a connection between a dashboard and a data source while presenting the data in a visually accessible manner. In our scenario, our objective is to populate our employee data within the layout that we created in episode 1. To achieve this, we'll select the list and navigate to the Properties panel located on the right side of the viewport. From the options available, we'll choose Data Source and proceed to select Employee Schema for the service. Additionally, we'll select Get All method to populate the data from the employee schema. As a result, our dashboard will be populated with the employee details. To further refine the data presentation, we can locally input the fields of the schema by right-clicking the controls and select the data source and choosing the parent control, which is the list, followed by selecting the required fields. Through these actions, we are able to seamlessly bind our data source to our dashboard's visual elements, ensuring the effective display and management of the employee details, as shown here. Once all the necessary bindings have been completed, it is imperative to consistently publish our modifications. We've successfully achieved data binding. Join us for our next episode to explore more exciting features. Welcome to episode 3 of our use case scenario, where we will explore click event interaction in the context of our low-code platform Behaviour. So far, we have learnt how to create app interface layout and data source binding. Now, what is click event interaction? So click event interaction allows users to effortlessly enhance the interactivity of your applications or dashboards without the need for complex coding. By implementing click events, user can define specific actions or responses triggered by users' interactions with various elements and the application interface. In our scenario, our objective is to populate relevant employee details within the pop-up window when a particular employee is clicked. We will continue to refer the schematic diagrams of the app interface that we created earlier. To accomplish this, we will select the container element and access the Properties panel located on the right side of the viewport. Within the Properties panel, we will navigate to the Interaction section and proceed to create an action which will open a pop-up window. Let's explore the process to accomplish this. In this panel, we can provide a title for the dialog header to create the pop-up. After that, we will design the pop-up according to our requirements. To initiate this design phase, we will introduce a foundational element known as a parent container. This container will serve as the overarching structure for the pop-up. Subsequently, we will create 2 additional containers, referred to as child containers, which will reside within the parent container. These child containers will be instrumental in organizing and structuring the content and elements within the pop-up, as shown here. The first child container offers a versatile canvas upon which we can strategically place both an image and a label component. To elevate the overall visual impact of these elements, we have the ability to meticulously tailor their appearance through the Style section of the Properties panel. This empowers us to exert granular control over color palettes, font selections, and a multitude of other stylistic parameters. By carefully orchestrating these design choices, we can cultivate a visually harmonious and captivating aesthetic within the confines of the container that have been done over here. Kindly observe our actions. At present, we are meticulously refining the visual aesthetics of our interactive controls by leveraging the capabilities of the Properties panel. Through the precise manipulation of parameters such as margin, padding, height, and width, we are able to exert granular control over the spatial arrangement, dimensional attributes, and overall placement of these elements within the user interface. This meticulous attention to detail ensures that the controls not only function optimally, but also contribute to a visually harmonious and intuitive user experience. Within the confines of the second container, we have the capacity to introduce a label component. Additionally, to further compartmentalize the content within this container, we can establish another child container. This nested structure allows for a hierarchical organization of elements, enhancing the overall structure and modularity of the design. Within this child container, we can establish two additional containers to further structure the content. We have the flexibility to dynamically adjust the vertical dimensions of these newly created containers to precisely accommodate the desired layout and content requirements. We can further enhance the display by incorporating 5 additional labels within the child container. These labels will showcase the desired employee details. By applying appropriate styling, we can ensure a visually appealing and informative presentation of the employee information. Let us see how this works. Upon finalizing the design, we can proceed to integrate data from our designated data source. To retrieve specific employee details, we'll establish a connection between the data and our container using the getById method. This method allows us to efficiently fetch the required employee information and map it accurately to the corresponding fields within the container, ensuring seamless data presentation. Through the strategic integration of click event handlers and the seamless binding of data to the user interface, we developed a highly responsive and user-centric application. This approach enables the dynamic display of employee details within a pop-up window, significantly enhancing the overall interactivity and user experience of the system. To ensure that these enhancements are reflected accurately within the application, it is crucial to consistently publish all actions and modifications made during the development process. Once the data binding process has been successfully completed, it becomes imperative to propagate these changes to the system by publishing them. This step is essential for maintaining data integrity and ensuring that the application functions as expected. Thus, we've successfully achieved click event interaction. Join us for our next episode to explore more on creating and applying behavior. Welcome to episode 4 of our use case scenario, where we will guide you through the process of creating and applying behavior on our low-code platform, Davum. In this scenario, we aim to visually represent employees based on their availability. Those who are available will be displayed in green, while the idle employees will be represented in orange. To achieve this, we begin by selecting the label corresponding to specific employee. Next, we navigate to the Properties panel located on the right side of the viewport and access the Style section. Within the Style section, we set the background color to green and save this setting as behavior with a meaningful name such as Available by accessing the 3 dots of the label in this section, as shown here. Following the same methodical approach employed for the available employee status, we proceed to configure the visual representation for employees designated as idle. A distinct orange background color is selected to visually differentiate this status. Upon finalizing this configuration, the newly defined visual style is encapsulated and saved as a discrete behavior aptly named as idle for future reference and application. We even have the flexibility to choose a color from our palette or specify a precise hue using a hex code. Proceeding to the subsequent step, we navigate to the Conditions section within the Properties panel. Here, we establish a specific criterion by selecting the Employee Status attribute. Subsequently, we apply the logical operator is equal to, followed by the value available. This conditional statement serves as a filter, ensuring that the subsequent actions are applied exclusively to employees whose status matches the specified criteria. To visually distinguish these available employees, we apply the previously configured behavior that was specifically designed for this employee status category. Following a parallel approach to the configuration established for employees with an available status, we proceed to define the visual representation for those employees currently designated as idle. This involves the creation of an additional behavioral rule within the system. By replicating the core steps of the previous configuration, we ensure consistency in the system's logic, while tailoring the visual output to accurately reflect the idle employee status. To establish a dynamic and accurate representation of employee status on the dashboard, we implement a data binding mechanism. This involves linking the employee status label component to the corresponding status value within the underlying data source. By forging this connection, we ensure that the displayed status information is consistently updated and reflects the real-time status of each employee, providing users with timely and reliable insights. Thereby, the finalized modifications are published. In conclusion, by following these steps, we have successfully created and applied the desired behaviors within the low-code platform Behaviours, wherein on clicking of a particular employee, a pop-up came up and the particular employee details can be seen. So in this way, we have created the layout, we have binded data, we have created click event interaction, and we have created an applied behavior. I appreciate you taking the time to watch this tutorial on creating a pop-up using click event and behaviors. Low-code platforms can be a game changer, and I'm glad to share my knowledge. If you'd like to see more tutorials on specific topics, let me know in the comments.